In this lesson, we will find normal percentiles using StatCrunch. So in our last example, we looked simply at z-scores, and we were looking to compare two z-scores to one another. In this case, we don't want to do that. We want to compare our score to how many scores or what percentage of scores would fall above or below ours. So in this case, we will need to find a z-score and then use technology to compute a percentile of either greater than our score or less than our score. Now there's many ways to do this, but in this class we're going to focus on using StatCrunch. So our question here is that we have an SAT verbal score of 680, and the scores follow the normal model of a mean of 500 and a standard deviation of 100. So what percentage of SAT takers did I score better than? That is what we're going to answer together. So I'm going to draw a picture, and again that's just for our benefit so that we know which direction we should be shading. We're going to find our z-score, which we already know how to do, and then we're going to use StatCrunch to find the corresponding percentage. That will be something new, and then we'll write a sentence that gives our solution. So the first thing we want to do is draw a picture. Now I'm going to draw my picture using the empirical rule just to give me an idea. So here I've got 500 in the middle, and I know that standard deviation of 100 says if I move to the right, it's 100 more, and if I move to the left, it's 100 less each time. And so here's my overall model, but I need to incorporate this 680, so somewhere in here. And I also need to incorporate the question, and the question says, who did I score better than? What percentage of people did I score better than? Which means I want to know what is the percentage of people less than my value, because these are all the people that had lower scores than I did. So I know that when I'm actually finding my probability, I'm finding the probability that it's less than or equal to my score, which is 680. Now, to find the z-score, we should be pros at this by now. We're going to take our observed, 680 is our observed, minus expected, which is always the mean, divided by the standard deviation. That gives me 180 divided by 100, which gives me 1.8. Now 1.8 is a great number that I can look at. I can say, oh, well, it's less than 2 standard deviations away, but we want to be more precise than that. So what I'm going to do is find the probability that z is less than or equal, so again the same direction, 1.8. And I'm going to find that probability. Now I need to use StatCrunch to do that, and I want to show you some things before I take you over to StatCrunch. So this is what our printout is going to look like, and I just went to Stat Calculators Normal. I want you to notice that whenever I'm using a z-score, I am going to use 1.8, which is my z-score here, and notice my mean is 0 and my standard deviation is 1. So that's always going to be the case when we're dealing with a z-score. And notice I've entered in 0 and 1 and 1.8, and I've made sure that this is going in the proper direction, and I find 0.964. So 0.964 is my z-score. Now, the answer to my question is that same value, except that I'm going to write it as a percentage. I scored better than 96.4% of SAT takers. Now, let's pop over to StatCrunch and take a look at those same answers. So here I'm going to go to Stat, Calculators, and Normal. And again, notice when I open Stat Calculators Normal, it just takes me to the normal model, and it already has the 0 and the 1. Now, a lot of people forget to choose which direction I should go, so I'm going to choose the less than. And here I'm going to enter my 1.8, which gives me 0.964. Now, that's great. And if you were doing, say, an assessment question, and I asked you to find the z-score and then the probability, you would certainly do it that way. In a case that is, say, a multiple choice question or something in StatCrunch or my stat lab that doesn't require you to show the work or find the z-score, we can cheat a little bit, which is just working smarter, not harder. So if I want to cheat or just check my work, notice I'm going to replace the mean with 500 and the standard deviation with 100, and I'm going to replace my z-score with 680. So it's very important that you're either using all standardized scores, which is 0, 1, and the z-score, or all raw scores, which is 500, 100, 680. But do notice that I do get the exact same value yet again, which is great. That's what we wanted. So let's do a little bit of practice. I want to find the probability that z is less than negative 4.2. Now, notice that this is a z, which means I can't have this 500, 100 in here. So 0, 1, and then here I want less than negative 0.42. And again, notice that negative, I knew that should be to the left of 0 because that would make it a negative value, and that means this should be less than 50%. So my answer is 0.337. I'm going to do the same thing. This time I'm going to switch it to 1.31, and I find the 0.0951. And then the last one, notice that z is less than negative 4. Now we talked about z-scores and how if it's more than 3, it's like really improbable that it happens. So notice here I get just a very, very, very small score, which is 0.00003167. Now for this last question, I want to take a look at a question involving height because I'm quite tall, so I get questions about it a lot. The normal model is that females are 65 inches tall with a standard deviation of 3.5. I am going to find the z-score, which is my observed value of 72 inches minus 65 divided by my standard deviation, and I end up with 7 over 3.5, which is 2. Now 2 is great, but again we want to look at drawing a little picture so we know which direction we should go. This is always 0 if I'm using the normal model, and here I am at 2, and my question is, do I shade right or do I shade left? Well, the question says how many people are taller than I am, which means I'm looking at these people that are greater than 6 foot tall. So if I pop over to StatCrunch and I change this to greater than 2, notice I get 0.02275. So back over here, 0.02275, and I would expect only 2.3% of American women to be taller than I am.